Hi guys, today we'll learn about logistic regression. Okay, so in the previous videos we have seen the linear regression, and we have seen that in the linear regression we have data, and in the next step we just multiply the feature component of the data with our weight, and we add some bias on that, and after that we calculate the loss, that is the difference between the actual label and the predicted one. Okay, so we calculate the loss, and the final step is just the optimization. Okay, we use gradient descent, various variant of gradient descent, to basically minimize this loss and to find the appropriate value of weights and biases. Okay, for that minimized value of loss. Okay, so we find the weights and bias, and after we get our minimum loss, okay, minimum point for this loss function, we have our weights and biases, or weights and bias for that particular minimized loss. Okay, and we note these WIs, weights and bias, for this, and these are nothing but the model parameter. We basically save these model parameters in the form of JSON file or in some other format, and we call that this is the model. So whenever we get some feature vector in future, we just multiply the component of that feature vector with our weights, and we add that bias that we already saved. Okay, and we tend to use our model, that is y is equals to sigma of wi and xi plus b, and we get the value of y but just by putting this value of x. Okay, so so basically this is very brief thing that I am telling you right now. We have covered everything in depth. We have explained the gradient descent and how the derivatives are being calculated for the linear regression in our previous videos. So if you want to dig deeper in this particular topic, you should be watching the previous videos. Okay, so this was some sort of revision for this. In this video we'll be knowing briefly what is logistic regression and how we can just think logistic regression as a variant of linear regression. Okay, obviously it is not same, but yeah, there are similarities. If we try to relate the things with linear regression, you'll find that a lot of things are, even the steps are very common. Okay, so what happens in logistic regression, we are given with the data, we have feature vectors, feature vector matrix, and this label. Okay, then what we do the same thing that we have done in linear regression. We basically multiply the components of our feature vectors with weights, and we add bias, and after that this is the new block here that I have added, and this is known as sigmoid. Okay, this is known as sigmoid. Okay, just wait. Okay, sorry guys, my pen just something happened. Okay, so this block is known as sigmoid block. This is not a block, basically I'm just drawing these in a block, in a block pattern, just to show that there are different components that we need to take care when we'll be creating our code for logistic regression from scratch. Okay, so this is sigmoid function. So whatever the output that will be getting after this operation, that is, here also our model is same. So our model will be y is equals to something like sigma wi xi plus b. Okay, it is just similar to the model that we had in our linear regression. Okay, and whenever after processing here in this block, in summation block, whatever the output will be getting, it will pass through this sigmoid block. Okay, and we'll know more about this sigmoid. What is sigmoid? Basically it's a function, and we need to pass this whole weighted summation from this function in order to get a value between 0 and 1. Okay, and after that we again try to calculate the loss, and we similar to a linear regression, we apply the gradient descent to optimize our loss, to minimize our loss, and to find out the model parameters that are that is weights and bias for the minimized loss. Okay, and these model parameters are then saved and in some format like JSON or in some dictionary format, and we call that saved file as a model, and later in future we can load that file, and we can just directly predict the values of y just by looking at the feature vector x. We need not to train it again. Okay, guys, here also you need to just look that this loss function here is this loss, like in our linear regression we calculated loss like this. Okay, so the loss was just the absolute difference of predicted value minus the actual value. Okay, but here in the logistic regression this loss will be log loss. We'll know more about this log loss. What is this log loss and how can we differentiate it? Because if we are performing gradient descent, then you can obviously, if you have seen the linear regression videos, you know that whenever we try to optimize, we need to calculate the derivatives of loss function. Okay, so here also we'll be calculating the derivatives of the loss function. So we'll see in next video that how this derivative of this complicated log loss function is calculated and what are the steps that are involved. Okay, even though if you are very familiar with the calculus, you already know how to do that. Okay, so this is the sigmoid function. As I said that there is a block here, you can see that here you can see this block here. This is a sigmoid function. So here whatever, if you'll pass z to this block, the return will be this function value. Okay, so in our case we are passing the weighted sum of our feature vectors. So the thing that we are passing is like summation of xi and wi plus b, right? This is the thing that we are passing here. So whatever will be passed, it will be in the 1 upon 1 plus e raised to power minus z format. Okay, and remember that the values that this function can give will be in 0 and 1, in between 0 and 1. Okay, that is why sometimes it is also known as logit function. Okay, and sometimes people say that it gives out the probability of the values. So and let's see what is log loss here. So basically guys, remember this video is just a brief about logistic regression, so don't worry, I'll be covering things in depth. So I'm just giving you an idea what is logistic regression and how actually it works in a broader picture. Okay, and this log loss here, as I already told you, that there in case of logistic regression we are not calculating that absolute loss that we used to calculate in linear regression. We are calculating log loss here. Okay, so log loss will be the formula for log loss is given by this summation, and this is the actual label for ith record, and this is the predicted label that is coming out from this sigmoid function. Okay, from this sigmoid function for ith record. And similarly, so these are the two things that we should be knowing, because there are only two variables, right? And the summation is taken for all the records, whatever the records that are present And so you must be thinking why this function has been taken as loss function. There can be a lot of functions, like we can take any variant of I x y I and y I cap, right? Why this function especially? So if you look into the mathematical part of this function, you will find that this log loss function is always a convex function, okay? And the mathematicians that are watching this video already know that the convex function, in the convex function, whenever we run gradient descent, it is very fast in convergence, okay? So the gradient descent will converge very fast. So so you can just think it as a mathematical convenience for programmers or for this algorithm, basically, to achieve the convergence faster. And yeah, obviously there are other reasons, but the reasons that are different from this one are actually not in the scope of this video, because then the video will be very big and you'll get bored and you'll just close this window and you'll just watch some movie, okay? So so you can see this is the log loss. So we'll be in the next video, we'll be looking at a logistic regression in a deeper way. We'll be looking at how this log loss function can be differentiated, and what are the steps that are taken into the gradient descent itself. When we try to optimize this loss function, we try to minimize this loss function so that we can get the optimum model parameters, okay? So the last step that I'm going to cover in this video is just some points that you should be remembering. You should always have these points along with you if you're going to face some sort of interview in machine learning or in AI, okay? So these are things that are related to logistic regression. First thing is that this logistic regression is meant for binary classification. This is very important, because like I have seen, guys, 70% times what will happen, that people will ask that why we use logistic regression. People will say that we use it for classification, and then the next question is what kind of classification. So the correct answer is binary classification. It cannot be used for multi-class classification, right? If you want it to be used in multi-class classification, then there are two approaches that you can follow. One is one versus one approach, and another is one versus all, okay? I'll be covering both of these approaches in the coming videos. This logistic regression is prone to outliers. If there are outliers in the data set, then definitely the decision or the accuracy of your model will be affected, okay? It cannot just take some sort of immunity to the outliers. It gets affected due to outliers, okay? This logistic regression is prone to missing values, so logistic regression cannot handle missing values. Guys, remember this, because in interviews these sort of single line questions are asked. They will ask whether the logistic regression is prone to missing values or not, okay? Next thing that is very important is feature scaling is required. So feature scaling is required in logistic regression. Remember, guys, whenever we use gradient descent in any algorithm, the feature scaling is required, because feature scaling always helps the algorithm to achieve the minima, like to achieve the minima for loss function faster, okay? So optimization of the minima function, the minimization of the loss function will be faster if you'll use the feature scaling, okay? And yeah, somehow it will boost your accuracy also if you are taking constant number of iterations, right? So if you are taking 100 iterations, for example, so for 100 iterations, what will happen if you have not used the feature scaling? The gradient descent will perform, and it will minimize loss to let's say like 10%, okay? But if you have utilized the feature scaling, what will happen in 100 iteration itself, your loss will be reduced to like 1% or something, okay? So you can see that there will be some improvement, so accuracy will be increased, okay? So this is it for this video, and I have just made this video so that a general basic understanding can be provided to the viewers. So it is not very specialized video for logistic regression, yet I think you got a broader picture of logistic regression, how you can see things, how you can relate it with the linear regression, right? Thank you for watching, guys. Just subscribe to this channel, share this playlist to other people who are looking for a job or who are having difficulty learning machine learning or AI stuff. If you have some idea, if you want to know anything else, just comment down in the comment. I'll be making other videos related to that point. Okay, thank you so much for watching this video. Bye.